So this is the MAT 2019 question 1J. Now, as soon as we start thinking about triangles, the first thing that jumps into my mind is always um, similar triangles. But in order to see that, you got to get a decent diagram drawn, of course. So if we start off here by drawing a roughly, oh, that's a terrible equilateral triangle. Let's at least try and get the base to be horizontal. Okay, there's our equilateral triangle. Now, our center O. Now, there's a little bit of very specific knowledge you need really to do this question, and that is the knowledge that if you draw a perpendicular from the corner to the opposite side, where they intersect is always going to be 2/3 along the length of that line. So whatever, if I was to call, we've got this as O. If I was to call this point A and this point D, I'm going to say that would C. Then OD is 1/3 of AD. Now, because these are all 1, I know that this is going to be 0.5 and AD, length of, is going to be root 3/2. Just using a bit of Pythagoras. So the next thing we're really asking ourselves is, well, what does this line look like? Well, this line is going to look something like this. Now, because of the symmetry of this triangle, ultimately, if we imagine this point being our variable, we'll call it point P. So this point can move between D and C. It doesn't matter whether it moves between D and B because that would just be a symmetry around AD. So if I was to put this over here, I'm just going to get the symmetry. If I was to consider it, and then the other edges, again, because it's an equilateral triangle, it's symmetrical. So the length I'm looking for is this P to O and then O to, say, Q. Now, the variable really is this angle here, theta, because wherever we put P and Q, they have to be on a straight line, POQ. POQ has to be a straight line. And so if we're considering PO to be, say, X and OQ to be Y, what we're really interested in is what they are as functions of theta, because it's easy to visualize theta moving as this line POQ rotates around O. Now, of course, the minimum theta can be is going to be 0, and the maximum it can be is 60, although we say less than 60, because at 60 it's just the same as it's at 0. But I mean, I could put an equal to there. It doesn't really matter as long as I recognize that at point D and at point C, you're just going to get the same thing, because once P is at C, Q is at this point here. So it's because of this 1/3 issue, we know that OD is therefore root 3/6, and we also know that O, if I call this point E, that is also root 3/6. Now, I've got this angle being the same as that, but I can't really make similar triangles because these two triangles aren't similar. That is not necessarily a right angle. This is a right angle, but that's not. But I also know this length. This is 2/3 of root 3/2. So it's just root 3/3. So if I look at the fact that that's 30, that's 90, I can quickly realize that this is 60 minus theta here. So OP is going to be, so that's Y. Y is going to be root 3/3 all over cos theta. And no, sorry, that's OQ, not OP. OQ. And the way we found that is by saying Well, that root 3 over 3 is this line here, and then the cos theta is, because I want the hypotenuse, so I divide by cos theta, because that's adjacent to this angle, and I want the hypotenuse, but OQ is the hypotenuse. And similarly, if I want this line, this is the hypotenuse of the triangle ODP, where OD is equal to root 3 over 6. So I can say that OP is going to be equal to root 3 over 6 all over cos theta. And I've just realised that's not cos theta, that's cos 60 minus theta. Now, if we look at those two, the whole length of the line, PQ, is therefore going to equal, well, that top one can obviously be written as root 3 over 6 cos theta, and the other one can be written as root 3 over 3 cos 60 minus theta. Now, ultimately, you're thinking, well, what value of theta is going to maximize this? Well, there's a little sort of issue here because of the 60 minus theta and the fact that theta can only go between 0 and 60. So we know from here that this function has a period of 60. And we also know that cos is an even function, so the net, cos of minus theta equals cos theta. So we can, from those two things, kind of guess a little bit that theta would be 30. And this is one of these things sometimes with the MET and the Tamura alike. You have got to have a bit of intuition. Once you've got to this stage, you don't want to spend too much time thinking about what value of theta is going to minimize it. It makes sense to check whether 30 will. Now, when you stick theta equals 30 in there, you end up with root 3 over 6 times root 3 over 2 plus root 3 over 3 times cos 30. No, sorry, this first one, cos 30 again, which is 3 root 3 over 2. And you ultimately end up with 2/3, which is D. And that is the answer. So you do have to put some thought into making this function. Like, you have to understand that as you rotate PQ, what's happening to that line. PQ is obviously variable depending on where P and Q are. So if it's a variable, what are you going to make it a function of? It makes sense to make it a function of theta. You could maybe make it a function of this length here, but then it's probably going to be harder to figure out how to maximize it, at least with the cos. When you've got trig functions, there's that periodicity to it, so it makes sense to go for a trig function rather than something else. I think the hardest thing to justify really is why the theta has to be equal to 30. So if you're a bit unsure about that, just let me know and I'll see if I can do a better job of explaining it. Thank you.